Okay, welcome everyone. If you're building with agentic workflows right now, you've probably felt this tension. There's massive industry excitement around multi-agent LLM systems -MAS, right? But then often the performance gains you see when you actually try to launch them are, well, minimal, sometimes even disappointing.
Yeah, it's a common frustration. You build these elaborate systems, multiple specialist agents all designed to work together.
Exactly. And then they frequently just fail to outperform a really well-tuned single-agent prompt.
Right. So why does that happen? Why do these complex systems often fall short?
That's the core question tackled in the paper we're digging into today. Why do multi-agent LLM systems fail?
A really important question for anyone in this space.
Definitely. Okay, so for everyone short on time, here's the 1-minute summary that cuts right to the chase. Basically, researchers analyzed the output of leading MAS frameworks.
And they found the failures aren't just random LLM hiccups. They're systematic.
Right, so they developed this framework, the Multi-Agent System Failure Taxonomy, or MAS. It categorizes 14 distinct failure modes across 3 big organizational pillars.
Those pillars are specification issues, interagent misalignment, and task verification.
The key takeaway, especially if you're a developer struggling with debugging these things, is recognizing that your MAS is probably failing predictably.
Yeah, they adapt that Tolstoy quote, successful systems all work alike. Each failing system fails in its own specific diagnosable way. MAST is basically the diagnostic map. It tells you which of those 14 problems is actually killing your workflow.
And maybe the most crucial finding, the fix isn't usually just waiting for the next better LLM to drop.
Not at all. It demands fundamental changes to your system's design, the coordination protocols, your whole architecture, really.
We have to look beyond just tweaking prompts.
Exactly. And to really grasp the scale of the problem, you need to look at their initial findings. We're talking surprisingly high failure rates in frameworks considered state-of-the-art.
Like ChatDev.
Yeah, they tested ChatDev, for instance, and found it only achieved about 33% correctness on the program dev benchmark.
Wow, 33%. Well, it's pretty shocking for systems hyped up to revolutionize software development.
It is. And this huge gap between the promise and the reality is why we needed to move beyond just looking at overall accuracy numbers.
Right. You can't just say, oh, it failed.
Yeah.
You absolutely need to know how it failed and why.
Precisely. And the way they built this MAS taxonomy was super rigorous. They didn't just guess. They used a deep qualitative method called grounded theory.
Which sounds impressive, but what does that actually involve? Sounds like a lot of work.
Oh, it's painstaking work. They analyzed over 200 execution traces. And each trace could be like 15,000 lines of text.
15,000 lines per trace across 200 traces from systems like MetaGPT, HyperAgent, AppWorld.
Exactly. And they had 6 expert human annotators meticulously going through this, refining the categories over time.
That rigor is important, though, right? It means the taxonomy isn't just subjective.
Totally.
Yeah.
They validated it carefully. They did inter-annotator agreement studies and got a Cohen's Kappa score of 0.88. That's really strong agreement.
So these failure categories are consistent, clear, people can reliably spot them, they represent real systemic problems.
Yeah, they're not just random interpretations. They point to fundamental organizational issues within the MAS.
Okay, before we dive into those issues, let's quickly define our terms. A failure in this context is just
simply when the MAS doesn't achieve what it was supposed to do, the task objectives aren't met.
And an agent is
defined by its prompt, its conversation history, the tools it can use.
Got it. And the MAS is just the whole collection of these agents interacting, orchestrated somehow.
Right. So let's get into MAS itself. The 3 pillars of failure. What's interesting is that the failures are spread pretty evenly across them.
Oh, really? So it's not like one category dominates everything?
No. FC1, specification issues, is about 42%. SE2, interagent misalignment, is around 37%. And FC3, task verification, is about 21%. It shows you need to pay attention to all 3 areas.
Okay, let's start with Pillar 1, FC1, specification issues. That's the biggest chunk at nearly 42%. What kinds of failures fall under this?
These are fundamental problems with the system's design. Maybe bad initial prompts or issues managing the state. They happen right at the start or early on.
So basically, the system either didn't understand the mission correctly or it kind of forgot the instructions partway through.
Pretty much.
Yeah.
And the single biggest failure mode they found overall, making up a whopping 17.14% of all failures, is step repetition, FM 1.3.
Step repetition, so the system just gets stuck in a loop.
Exactly. The agent or the whole orchestration just cycles through the same steps over and over again, probably because the setup is too rigid, like you said.
Yeah, like it's just spinning its wheels, it does something, doesn't check if the state actually changed meaningfully, and just tries the same thing again. Okay, what about the one that feels maybe more human? Disobey task specification, FM 1.1. That's about 11%.
Ah, yes, this is where we get insight one from the paper. They argue really convincingly that this failure agent not following the specific instructions is often fixable by improving the MAS organization, not just by hoping for a smarter base LLM.
Okay, how did they show that? You mentioned a case study with ChatDev earlier.
Right, so they asked ChatDev to build a Wordle game. Pretty standard task.
Yeah.
But they specifically asked for a daily changing word.
Okay, seems clear enough.
But the system failed. It built a game with a fixed word that never changed. So they thought, okay, maybe the prompt wasn't explicit enough.
But they tried again.
Yeah, they made the prompt even more explicit. They spelled it out. Randomly select a new 5-letter word each day.
And did that work?
No. It still produced code with a fixed word. And worse, it introduced completely new errors elsewhere in the code.
Wow. Okay, so that really does suggest the problem wasn't just the LLM misunderstanding the instruction.
Exactly. It implies the MAS's structure, its internal organization, was somehow unable to incorporate that specific requirement correctly across all the agents involved. The orchestration itself seemed to mess it up.
That's a critical insight. What other big failures are in this specification category?
Well, there's unaware of termination conditions, FM 1.5. That's nearly 10% of failures. The agents basically solve the problem, but then just keep talking and processing.
Wasting time and tokens.
Yep. And the classic loss of conversation history, FM 1.4, about 3.3%. The context window gets truncated, and agents suddenly forget what happened earlier, reverting to old states.
Okay, so that covers the big system design and understanding flaws. What's the second pillar?
Pillar 2 is FC2, interagent misalignment. This makes up about 37% of failures, and it's all about breakdowns in how agents interact and coordinate during the task execution.
Ah, the AI equivalent of office politics or departments not talking to each other?
You could say that. And the biggest failure mode here, at almost 14%, is really interesting. Reasoning action mismatch, FM 2.6.
Reasoning action mismatch. What does that mean?
It means the agent's internal thought process, which you can often see in the execution trace, says one thing, but the actual action it takes is completely different.
Huh. Like an employee writing a memo saying, we absolutely must switch to the new system, but then they send the final report using the old broken system anyway.
Exactly like that. It suggests a serious disconnect between the planning part of the agent and the execution part, a major reliability issue.
Yeah, definitely. What else falls under misalignment?
Another big one, very relatable, is fail to ask for clarification. FM 2.2. That's over 11%.
The agent that just plows ahead with a wrong assumption rather than stopping to ask a necessary question.
Yep, just to keep things moving. But the cost of that assumption can be really high in these complex systems.
I bet. Are there smaller, maybe more subtle communication glitches too?
Yeah, even low percentage ones can be critical, like information withholding, FM 2.4. It's only 1.66% of failures. But when it happens,
it can be devastating, right? I think you mentioned an example.
Yeah, the App World Phone Agent case study. It illustrates this perfectly. One agent correctly figures out a crucial piece of information like the username needs to be a phone number for login.
Okay, vital detail.
But then it just fails to tell the supervisor agent orchestrated the login process.
Oh, no. So the supervisor just keeps trying with the wrong format?
Repeatedly. And the whole task fails. Just because that one critical piece of info wasn't shared, it shows how a single communication failure point can completely derail everything.
That's brutal. Any others in this category?
Well, there's the rarest, but maybe most frustrating one. Ignored other agents' input, FM 2.5. Tiny percentage. But imagine seeing an agent acknowledge a correct suggestion from a peer and then just ignore it and stick to his own wrong plan.
Yeah. Internal politics, but in code. Okay, that brings us to the third and final pillar.
FC3, task verification. This is the quality control stage post-execution. It accounts for about 21% of the failures.
And what goes wrong here? Is it just that the verification fails?
Pretty much. The main issues are no or incomplete verification, FM 3.2, and incorrect verification, FM 3.3. Together, those make up over 13% of all failures.
So the system finishes the task, claims it's done, maybe even runs some checks, but the output is still wrong or incomplete, and it gets approved anyway.
Exactly. The stamp of approval goes on garbage output.
And this leads to their insight too, right? That verifiers aren't the magic fix everyone hopes for.
Definitely not a silver bullet. They found that even systems designed with specific verification steps, like ChatDev again, still had those really low success rates. So why?
Why the verifiers fail so often?
The core problem seems to be superficiality. The verifiers often only check low-level stuff. Does the code compile? Are there comments in the code? Basic linting, maybe.
But they don't check if the code actually does what it's supposed to do according to the high-level requirement.
Precisely. They miss the business logic or the core rules. The paper gives a great example. A chess program, generated by ChatDev, passed its verification step.
Yeah.
But the program still allowed illegal chess moves. The verifier never actually checked the output against the rules of chess.
Right, so just bolting on a verification step at the end isn't enough. The verification itself needs to understand the actual goals of the task.
Exactly. It needs depth.
Okay, so MS diagnoses all these problems. But is it just an academic exercise, or can developers actually use it?
No, they specifically worked on making it practical. They developed an automated LLM-as-a-Judge pipeline that integrates the MAST taxonomy.
Ah, so you don't need 6 human experts reading 15,000 lines of text each time.
Right. They validated this automated judge against their human annotations and got a pretty good Cohen's Kappa of 0.77 with few-shot prompting.
So that means a developer could run, say, hundreds of test runs of their MAS.
And quickly get back a breakdown saying, okay, 40% of your failures were specification issues, mostly step repetition, and 30% were misalignment, mostly reasoning action mismatch, and so on. It massively speeds up debugging.
That sounds incredibly useful. Does it work on different kinds of systems too?
Yeah, they tested its generalizability. They applied MAST to mass architectures it hadn't seen before, like Magentic 1, and used different benchmarks like GAIA, and still got high agreement.
So it seems to capture fundamental problems in how these agent systems are organized, not just quirks of one particular framework.
It's the idea. It points to foundational issues.
And the real proof is in the pudding, right?
Yeah.
Did using MAST actually help fix the systems? They did intervention studies.
They did. And this is where it gets really interesting. They took ChatDev, identified its weaknesses using MAST, and tried targeted fixes. For instance, they improved the role prompts for the agents to address specification issues.
Okay, like better instructions for each agent.
Yeah. And that gave them a solid plus 9.4% increase in success rate. Good, but maybe not game-changing.
Right, an improvement, but still failing a lot.
But then they targeted the organizational structure itself. Based on the math diagnosis, they made architectural changes. For example, they added an extra verification step, but one specifically focused on the high-level task objectives, not just superficial checks.
Addressing that verifier superficiality issue we talked about.
Exactly, and that architectural change yielded a much more substantial plus 15.6% absolute improvement on the program dev tasks.
Wow, okay. That's a much bigger jump.
It really is. And this, for me, is kind of the mic drop moment of the paper.
How so?
Because MAST clearly showed that making these deeper topology-based architectural changes, like designing a better workflow, maybe adding a review cycle, focusing verification on goals, was consistently more effective than just tweaking the prompts.
So the way the system is organized is the software, in a way. The structure matters more than just the instructions given to individual parts.
That's the strong implication, yes. If you tie all these threads together, the conclusion seems pretty robust. MAS failures are deeply rooted in organizational design, communication protocols, coordination structure.
Just like in complex human organizations.
Completely consistent with those theories. We seem to be hitting the limits of system design, maybe more than the limits of raw LLM capability right now.
The system fails because the organization is flawed, even if the individual agents are potentially very smart.
Right. But the paper does leave us with one big, crucial open challenge that MASH, in its current form, doesn't really cover.
Okay, what's that?
Efficiency. Correctness is obviously essential, but many systems that eventually get the right answer might still fail the real-world test because they take too long or cost too much.
The latency and cost problem.
Exactly. They observed agents having these incredibly long, sometimes redundant conversations to achieve simple tasks. Remember that App World example?
Which one was that?
The one where the orchestrator agent and a Spotify agent took something like 10 back-and-forth steps just to retrieve 10 songs.
When logically, one well-formed API call should have done it.
Precisely. That kind of inefficiency just explodes the cost and the time it takes to get anything done.
So correctness is only half the battle.
It really is.
Yeah.
And it suggests the next step might be developing ways to diagnose and mitigate These efficiency failures, things like unnecessary latency, inflated token costs, excessive computation, those are just as critical for actually deploying these things.
Okay, so wrapping up, we leave you, the listener, with maybe a final thought to chew on for your own work. Given what we've seen here, especially the demonstrated inadequacy of current superficial verifiers.
The ones just checking if code compiles or the output format looks right.
Right. Given that, what does it really mean to design a truly robust, reliable multi-agent system?
The paper strongly suggests the path forward isn't just hoping for a final check at the end to catch all errors. We need to move beyond that.
So what's the alternative?
Future work, both research and development, really needs to focus on designing multi-level verification strategies. Think about how we do testing in traditional software.
Like unit tests, integration tests.
Exactly. Apply that thinking to MAS. We need verification integrated throughout the entire workflow. Modular checks, continuous integration principles applied to agent interactions, ensuring those high-level requirements are validated at multiple stages, not just looked at hopefully at the very end.
That sounds like a much more rigorous and likely more effective approach.
It's probably how we bridge that gap. We started with the gap between the massive excitement around MAS and the often frustrating reality of making them reliable and efficient in practice.
A challenging but necessary direction. Great insights from this paper.
Definitely a valuable framework for anyone building these systems.